Howdy, everybody. Hope you're doing well wherever, whenever you are. We're moving on to year 2016. Um, so yeah, again, like last time, I think 2015 went pretty well. Felt like I learned a lot, but here we are for 2016. Just gonna give it a go. You see, I updated the little image down below. Apparently, a bunny stole our stuff. I read the first couple paragraphs just to figure out what like the thing you're doing is, so I could try and update the graphics and stuff. So anyway, let's just get started with day one. See what happens. It's no time for a taxi cab. Santa's sleigh uses a very high precision clock to guide its movements, and the clock's oscillator is regulated by stars. Unfortunately, the stars have been stolen by the Easter Bunny. To save Christmas, Santa needs to retrieve all 50 stars by December 25th. Collect the stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first puzzle. Each puzzle grants 1 star. Good luck. So that's kind of the intro to the thing. So apparently the Easter Bunny has been bad and we're going after him. You're airdropped near Easter Bunny headquarters in a city somewhere. Near, unfortunately, is as close as you can get. The instructions on the Easter Bunny recruiting document the elves intercepted start here, and nobody had time to work them out further. The document indicates that you should start at the given coordinates where you landed and face north. Then follow the provided sequence. Either turn left or right 90 degrees, then walk forward the given number of blocks, ending at a new intersection. There's no time to follow such ridiculous instructions on foot, though, so you take a moment to work out the destination. Given that you can only walk on the street grid of the city, how far is the shortest path to the destination? So that's like a Manhattan thing, I think is what it's talking about. We'll check it out. For example, following R2L3 leaves you 2 blocks east and 3 blocks north. So you're like facing, pretend this is north, and then R2 would be this way. Or I guess for you guys, maybe it's this way. I don't know. But you go 2, and then you go left, and then you go 3. That puts you 5 blocks away. I guess the left puts you right back this way, right? So you go back up. R2 leaves you 2 blocks due south of the starting position, which is 2 blocks away. Yeah, because you go and then you're just 2 blocks away. R5, L5, R5, R3 leaves you 12 blocks. So like 5, 5, 5, 3. Put you 2 closer, a few closer. Okay, how many blocks away is the Easter Bunny to begin get your puzzle input? So we've got a bunch of comma separated commands. It looks like on one line. Okay, so yeah, like I said, there's this thing, Manhattan distance. Yeah, taxicab geometry is what they call it here. The idea is you can only go in like these triangle places, and the way that you calculate it is the difference of the absolute value of the difference of the x's plus the absolute value of the distance of the y's. And the way to think about that is like the equivalent of going like this is like the equivalent of going all the way up to the top and all the way over to the right. Like you're essentially running the same length. So you just, like this right here, the absolute value of the difference of the x's plus the absolute value of the difference of the y's. So that's how you'd calculate the taxi cab geometry. So now I think the thing to think about is like what commands, how you want to like do the commands. So, you're starting north. We probably want to have like some like position or point structure. And when it says right, like we or the direction we're going is like this way, which is y positive 1 and x 0. And then when we go right, we want to turn this way, which is y 0 and x positive. And so like we'll kind of like alternate between those, if that makes sense. And then we just follow that many directions. So we want to know like where we end up, like where we are at the end of all of that. And then we can just calculate our Manhattan distance from 0, 0 to that distance. And that will give us part 1, I think. It's probably the way to think about it. So let's do that. So I think we need, let's start with a type or a struct point x, which is we'll make it an I size, and y is an I size. And we'll impl point, how about we impl default for point. And we just want to return point 0, 0, like that. So I got to do this. Probably have x's and y's. So that will give me like the 0 point. And now we probably want to do the rotation. So like you give me a right or a left. How will that work? I'll think about this, because you probably want your current direction and then how far you go. Where does that put you? We want to know which way we're facing, but that can be like a point as well. And then we want to go forward that direction. So if we, it wouldn't be here, but if we have like actually, I'm going to put it down here. We have a struct position, and that, or struct I mean, I guess we can call it like it. I'm thinking like it's my position. And so what I would do is something along the lines of, I'd have a direction, which is a point, and a location, which is a point. And then we could impl position, and we could say, we can do the default to for this one, because we're going to start at 0, 0, and we know we're going to be facing north. That is, x goes 0, y goes 1. Like that. For position. What doesn't it like about these? Oh, I can't. Direction and location. Like that. So now we can implement position with some functions, right? So we can say fn move, and you give me a direction, which is a car, and distance, which is an U size, I guess. Although these are, what are these? I sizes. We'll make them I sizes just so we don't have to do any casting. So how does that look? So if we're facing north and we go left, we want to go facing east. I think I kind of have to draw this out in my head. I'm sure there's an easy way to do this. It's like left would be x minus 1. No. I may have to look this up. Because I'm thinking, like, how do you do this rotation? So you say like it would be like I should do mute self. So it'd be like self dot direction is equal to match direction, and if it's L, we want to come up with a new direction. I don't know what it is, but we had the same for R. Like that. But I may have to, I'll have to think about this a little bit. So if whatever your direction you're facing, if you're going like let's say, like I almost want to write it out. If you're going north, you're at 0, 1, like your delta, your direction is 0, 1. And then if you go right, think about going right, you're now going 1, 0. And then you're going, if you go right again, you're now going 1, negative. Sorry, 0, negative 1. And then 1. I can't think of an easy way to do this. Oh, move is an identifier. That's what that error is saying. We can call it like walk. So I almost want to have like a direction map. So like if we impl point and we say change direction, and you give me a direction car, I'll give you a new point. And so what would that be? We'll do like a match car. Ooh, actually we can match on self and direction. And so we can say something like this, x 1, y 0. There's probably an easier way to do this. I just can't think of it. So if this would be negative. So I need to do these for 1, 1. Oh, no, there's so X is 1, Y is 0, is going this way. So turn left would be 1, and turn right would be oh, maybe I am seeing a pattern now. The 0 value becomes the new value, and R is negative. Well, we'll keep doing this. So we want this negative value right here. So on these, so if we're going down and we turn right, like if I'm maybe if so, if this is down, this is up. Down, turn right. Would have me going in the negative X. And this one's the positive X. So these are just rotated. Like that. One of these. It does feel like there's a pattern. The 0 value becomes a non-zero value. And then if you're going right, those become the same. Those become the same. Those become the opposite. Those become the opposite. I don't know. Who knows? I think this is right, though. We'll find out. This is the place that I'm most likely to feel like we've made a mistake. But let's impl add and multiply. So impl add 4 point. Is this the right? Oh, I need to add a type output like this. And we'll also impl mul. Like that. Probably gonna have to derive. And then now we need the Manhattan distance between 2 points. Actually, that one's not too tough because we start at 0, 0, so it's just the absolute value of those. So this one I actually and then I want to say like self.location plus equals self.direction times distance, like that. Oh, I need to mul impl mul my size. Like that. That's what I actually want. It wants me to implement add a sign, but I kind of want to check to make sure it works first. Okay, my input is actually just going to be a vec of car eye size. And so I'm going to do input split something like that. String indices are of range U size. Type stir. Huh? What's happening here? Okay, that part. Oh, that was it. Was that it? Why won't it let me string indices are of range U size? Why won't it let me? It doesn't like that I'm using. Like, does it want me to do something like this? Mm. Looks like it doesn't know what this is. Is that right? Oh, is that what it was? Do I not need this? I used bytes instead of cars. Yeah. Okay. Um. So we just do let moot cur equal position default, and then we do for direction distance in input dot input. I probably going to do that. We say cur dot no walk. And then this one's is just cur dot x dot absolute value plus cur dot, oh, it's not x, it's cur dot location dot x dot abs. It's cur dot location dot y dot abs, like that. Oh, it's the other way around. Like that. So can I do like this? Okay, yeah. Nope, it doesn't like that. Okay, so I'll do this. Like that. That. Probably need to trim it. 241. What are the odds? Okay. Woo-hoo. I think I was most worried about this part of it. There's probably an easier way to do that. We'll look that up. To be honest, that felt a little slow for this type of problem. Maybe I need to be thinking more about how I do it. But okay, I mean that wasn't too hard. Um yeah, again, if I was speed coding or whatever, I'd probably want to know, doing it competitively, know this by heart. Um these weren't too hard, maybe not think about it so much. Why was the parsing so hard? That's interesting. We can look at that. Yeah, but then this works. Okay. Move on to part 2. Part 2. Then you notice the instructions continue on the back of the recruiting document. Easter Bunny HQ is actually at the first location you visit twice. For example, if your instructions are R8, R4, R4, R8, the first location you visit is 4 blocks away. Due east. Oh, because this 8 will have you pass through this initial 8. Is that right? Go like 8, 4, 4, 8. Okay. I'm still not convinced that these are right, so this one will definitely test my patience. What it means that I want to probably do is do this walk one at a time and then track them. So we go like this. We'll create a hash set. And so we'll do this, and then we'll go 4, 0, 4. We walk right here. And then each of those we say if scene dot contains cur dot location. Want to break the outer. And then we still return this. What doesn't it like about these now? Oh, I need to impl equal partial equal hash. This is 1. Oh, I haven't renamed it. It's definitely not 1. Oh, I move. When I do my walk, I change my direction. So we call for P2, we want to call change direction here. And then we call step here. We can probably combine these later. Yeah. Still 1. So I change direction. And then for distance, I call step. And I see if that thing is changed. Didn't I do? Oh. Why is that? Oh, is this a knot? Yeah, there you go. Adds value to set, returns whether the value was newly inserted. Yeah. So, yeah, okay, there we go. I presume that fixes it. 116. Trade. We got it. Okay. Yeah, that wasn't too hard. So, how do we feel about day 1? It took probably longer than it should have. Yeah, I don't think it's too tough. Again, we're returning the Manhattan distance, so it's relatively easy just because we're starting at 0, 0, just to return the sums of their things. We could add a distance function there. I feel like the parsing is okay. Parse L cars and 0 unwrap. Yeah. Cur walk direction. What didn't oh, this add a sign. How does add a sign work? I just do this. Oh no, but I just do self.x plus equals h s.x and self.y plus equals rh s.y. Like that. So that will allow me to do like that. Do I want to do anything more interesting with these? could have like the walk return all of the new values. Because this is like mutable too, so I'm just changing this. Like the for loop seems okay, but we could also do input dot for each. Is that even the same answer? Oh, because I do it multiple times. Yeah, I don't know if this is any faster, right? Or cooler. Not really helpful. I guess they call it taxicab distance from 0, 0. Like that's what this is. Normally you'd subtract the two values and take the absolute. But because it's 0, it just becomes add the x's and the y's. Yeah, could you simplify this a little bit? I think the most interesting thing is to simplify this. So I'm inclined to kind of Google it, or ask something. Should we try ChatGPT today? I have a direction like north represented as an x comma delta, and I want to change the direction if given an R or an L for turning right or left. So 0, 0, 1, and then R would be 1, 0. How could I do that in Rust? Let's see. Let's see what it says. Negative. Oh, I thought I saw this pattern, but it didn't quite look like it worked. Okay, let's try that. So it'd be match direction. R would be self.y negative self.x. L would be self dot negative self dot y self dot x. Oh, these are points. That 241, 116. Is that the same? Mm-hmm. Okay, so that feels much cleaner. That's something worthwhile. Yeah, okay. We spent enough time worrying about this one. Probably. I mean, we can make more adjustments as we need to, but I think that's a fairly easy start. There was nothing crazy in this day, I guess. Yeah, figuring this out made me think for a minute, kind of lose track of time doing that. That's good to know though, is like you're literally just switching the X's and Y's, and you're negating the X if you go left and the Y if you go right. Okay. That'll be good to keep in mind. Anyway, there you go. There's day one in the bag. I'd love to see what you guys have done, how you solved it. Maybe did you do it differently? Was it worth it implementing all these add assign molds? Maybe not, especially if you're doing it competitively, because you actually only do this stuff right here, right? So it's probably faster just to do it right here. But it does make these look cleaner and simpler. So, yeah, tell me what you think. You could probably tighten up this for loop. Like, for example, have this step function. Instead of doing step, you could have like the walk function return the points. It's worth a thought, worth a try. So, anyway, tell me how you did it. Love to see how you solved it. And that's it for day one of 2016. Thanks, everybody. Talk to you later.